In this video, we're going to be building a super bright LED keyring torch. So before we take a look at the components we're going to need, I'm going to do a brief explanation of how we come about choosing the correct value resistor to run our LED off two button cell batteries. If you're not interested in the explanation, then click up here, it'll jump forward in the video to the overview of the parts we'll need and then the build. So the first thing we need to know is the specifications of our LED, namely its typical operating voltage and also the maximum current we can feed it. Now I'm going to list those specs on the side of the video so you can see. Now we're going to be running the LED from two button cell batteries. These are 2032s. And typically they have 3 volts per cell, so we've got 6 volts in total. Now if you do the math, that should mean that to run our LED here from a 6 volt power source, we would have to then have a 33 ohm resistor. However, that's not the case when we're running them off these button cell batteries. Now why is that? Well, button cell batteries have a very high internal resistance, and this means that they can't output massive amounts of current. So as soon as we connect our LED, if we had a 33 ohm resistor, it's not going to conduct 80 milliamps, so we're not going to get full brightness. So to show you this or demonstrate it, I'm going to hook up my LED to my multimeter here. Now first I'm going to test the batteries. These are brand new batteries, so you can see we're almost getting bang on 6 volts. Now if I connect our LED here and light it up, and now I probe the voltage of the batteries, we're only getting about 4.3 volts. So the voltage has dropped significantly because of the current draw from our LED. To demonstrate this further, I'm going to switch my multimeter to milliamps, and we're going to see how many milliamps this LED is drawing. So you can see there that we're drawing just shy of the 80 milliamp rating, kind of holding steady around 70. It's going to drop slowly over time. So in a nutshell, what's going on here is the batteries are unable to supply the current this LED can consume at 6 volts. So the voltage, as soon as the LED is connected, drops down to 4 volts, and that means that we can run this LED off a 15 ohm resistor rather than a 33 ohm resistor, which you'd use in conjunction with a 6 volt power source in normal circumstances. You might also have concerns about running this LED, which is rated at 3.4 volts, running off our batteries, which can feed at 4.3 volts. Now there's actually no problem here. We can run LEDs at a higher voltage than the manufacturer's rating just fine, provided we don't exceed the current rating of our LED. And basically we're only feeding it another volt. It's not going to cause any problem provided we don't exceed the manufacturer's current rating for the LED. So as usual, all the links for the parts I've used will be found down in the video's description if you want to purchase them. So I'm running some Energizer 2032 button cell batteries. We only need 2 of them. We've got some small M3 countersunk self-tapping screws, small piece of heat shrink tubing, an LED. Now this is not your typical garden variety eBay LED. This is a super bright LED that's made in Japan. This is a 15 ohm resistor. There will be a link in the video's description to 3D print this housing, and you're also going to want some epoxy glue. So our resistor needs to be soldered on to the positive leg on our LED, and if you don't know what that is, that's the longer one. Now we're going to want to trim off the lead fairly short, and don't throw away this little clipping of metal. We do actually want to keep that. And also trim one of the sides of the resistor quite short as well, about the same length as the lead on the LED. Now typically LEDs do not like being heated up very long as it starts to melt the plastic, so we're going to try and do this in a timely fashion. I'm going to hold the resistor in place, just a quick dab with a soldering iron, and now our resistor is soldered onto our LED. And remember the bit of wire I said to save from the LED? Well, we're going to solder that back onto the LED onto the leg that we're going to connect negative to. So it should look something like that. So before we mix up any glue, we want to make sure that our LED fits in the mounting hole in the front of our enclosure. If it doesn't, then just drill it out with a 5mm drill bit. So I've got my 2-part epoxy here. I'm just going to mix it up. And we're going to install our LED in the enclosure with the resistor facing down. You only need a good, I suppose you'd say, a drop of epoxy. Just going to let this gravity do most of the work for me. We don't need much to hold it there. So next up we can install the heat shrink tubing on the top lead from the LED, which is negative. And we kind of want about 3 to 4mm of wire protruding out from the heat shrink. Now, depending on how lucky we get with where the wire's bent and positioned, we might have to put a couple tweaks with the needle nose pliers, but we'll save that for later. So now we're going to install our button cell batteries. Now, you can see these batteries are clearly marked positive on one side, so positive side gets installed facing down. And if we push the lead down, we can get our LEDs to light up. So, you can kind of see what's going to happen here. We're going to install our top cap, and if I push down, we can see the LED's not really turning on consistently, and it's also staying on. So I'm going to tweak the wire, bend it up, bend it down, do whatever until you get the switch working really nice. I've actually got quite lucky. It's working superbly now. So now we can install our 4 screws on the top cover. So that about wraps it up for this video. I hope you enjoyed it. Quick little fun project and a very useful one at that. So if you enjoyed this video, please give it a like, it'd be much appreciated. And if you loved this video, I'm sure you'll like a host of other videos. Do hit that subscribe button, it's 100% free. And that, thank you very much for watching. I'll see you in the next one. Bye for now.